Welcome to this instructional video of the heating plant installed at Steep Road. We have fitted two 80 kilowatt gas-fired Wiesmann boilers. They directly heat this 1000 litre buffer tank to 75 degrees Celsius. The boilers are controlled via the Wiesmann Vitronic 300K unit. This unit will detect any faults within the system as we have simulated here. In the majority of situations, only one boiler will be required. The 300K will swap the boiler's demand signal every month so they wear evenly. In the event of a high demand situation, the 300K will bring in demand to both boilers simultaneously, providing 160 kilowatt of power. In a fault situation, the 300K will run the single working boiler until the faulty unit is repaired, thus ensuring continuity of heat in the buffer tank. Heated water from the buffer tank travels down the pre-insulated pipework and into a second, smaller buffer tank, situated in the basement. From this smaller buffer tank, heated primary water is transferred around the heating system. It also indirectly heats two 400 litre domestic hot water cylinders, shown here, for washing, etc. The top thermostats on the cylinders control the temperature of the hot water contained within. The lower thermostats control destratification pumps, which are used to mix the water within the cylinders so they are of an even temperature. It is important to maintain adequate heat to prevent Legionnaire bacterial growth inside the cylinders. There are two expansion tanks in this area which require engineer maintenance annually. Annual maintenance will also be required on the primary expansion tank in the basement. The ultraviolet filter will require twice annual maintenance. All pipes in this area have been insulated to prevent heat loss and cross-contamination. On critical pipe circuits, we have used twin-head pumps. Like the boilers, they sequence between each other for even wear, and in a failure situation, the good pump will maintain flow through the circuit. In low occupancy situations, one hot water cylinder can be isolated from the water supply via this switch, which activates an electric solenoid, closing off water to the cylinder, but maintaining heat to kill bacteria internally, therefore eliminating Legionnaire bacteria. The hot water from the cylinder is pumped around the property and controlled via this timer. Inside this plant room, there are one of two fast fill points for the heating system's primary water. This gauge indicates system pressure. In the top plant room, there is the second fast fill point as operated here, along with a second pressure gauge. System pressure is automatically monitored and increased as required via the Grundfos pressurization unit. A third pressure gauge can be seen on this unit, indicating heating system pressure. Excess pressure in a fault scenario would be expelled via this safety pressure relief valve. Shown here is a second primary expansion vessel. Having two buffer tanks heated in this way allows the system to maintain comfort inside the house for approximately 24 hours, even in a fault scenario. For example, gas outage. The domestic hot and cold water at the property is boosted via two Lawara pumps. As with the boilers, the pumps individually sequence between lead and slave unit, firing together under high demand scenarios while ensuring backup under a fault situation of one pump. Isolation of the pumps electrically is via this radial switch. We have installed a split 2,500 litre GRP potable water tank, supplied with fresh water from the mains. As you can see, there are 2 fill points for this tank and 2 outlets. This has been done for low occupancy situations to prevent stagnation of the water contained within the tanks. To drain the larger tank, isolate this supply valve as shown. Then turn off electrical power to the boost pumps. Now we are ready to drain the large side of the tank via the main discharge pipe to the drain outside. Valve 20 should be closed to maintain water in the smaller side of the tank. Valves 17 and 18 on the pump should be closed as shown. Now, valve 12 should be opened and the larger tank will begin to drain. It will take around 10 minutes to fully drain. Once the tank is drained, valve 19 should be closed again. Valve 17 and 18 at the pump can be opened. It is important valve 12 is now closed. Opening valve 20 re-establishes supply to the pumps. Power can now be reinstated. Now only 400 litres are being stored in the tank. To reinstate full storage capacity, simply open valve 19 and turn on the supply to the tank as shown. It is important under full occupancy the entire tank is filled. Water travels from the tanks to the basement plant room and through this ultraviolet filter for disinfection without chemicals. It is important this unit is maintained. Any faults will show at this control panel. The pressure of the water is then reduced at this valve and distributed via pipework in the basement plant room and to the hot water cylinders. In this plant room are isolation valves for all areas of the house, thus enabling components to be serviced while maintaining continuity of supply to the home. The buffer system means the house will stay warm for 24 hours, even with no heat input. We have installed twin-head primary pumps for inbuilt redundancy and reliability. The 1,000 litre buffer tank is ready for solar integration via the inbuilt solar coil, and the spare tappings are ready for renewable energy such as biomass or heat pumps. The 300K controller can adapt to integrate additional heat sources in the future. We hope the system provides many years of reliable service. Thank you for choosing Prestige Plumbing and Building for this project.